All right, so this is the second to last review for the semester, unless you're lucky enough to get to take the final exam. The nice thing about this chapter is most of our problems can be checked on our calculator even before we start doing the problems. When I did problems from section 8.1, which is where the first few problems come from, I didn't use my calculator to check because I didn't have matrices at my disposal. But if I'm doing problem 1, especially because of the nasty fractions, probably the first thing I would do is check the problem or get an answer via my calculator. And in order to do that, both equations need to be, I'm going to use RREFA, and the bottom equation needs to have the y moved over. So I'm going to move the y over, subtract y from each side, and get that to be my bottom equation. So I'm going to live with the original top equation in the unpleasant fraction form and have the rewrite of the bottom equation. And I'm going to enter this matrix on my calculator. Without that vertical bar, and do RREFA. So this is going to be a 2 by 3 matrix, and I'm going to enter it in matrix A. I'm going to do RREFA, and it has nothing to do with how I'm going to solve the problem by hand, but this is the quickest way for me to generate an answer so that when I do this by hand, I know whether my answer, if I made a mistake or not. So now I'm going to enter this second matrix, go over to the edit, type in 2, enter, 3, enter, and then go 4 divided by 5 for the 4/5, gives me a decimal, but I'll live with that. 1 divided by 4 for the 1/4. Looks reasonably entered correctly, other than I see decimals as opposed to fractions, but I can live with that. Quit out of that. Second matrix, math, arrow up or down to find RREF. Second matrix, enter, enter, and that leads me to the matrix 1, 0, 5, 0, 1, 4. So the answer to this problem that I'm shooting for is going to be x equal to 5, y equal to 4, and when I write my answer, when I actually do the algebra, I'm going to write 5, comma 4. My algebra comes up to an answer different than 5, 4, first I'll dig through my algebra to see if I've made a mistake, and then if I can't find a mistake in my algebra, then I'll come back to this sheet, because there's a chance that I did something wrong on my calculator, but I don't think so. I think 5 and 4 is perfect. I could check that even further by hand, but I'm not going to take the time to do that. So I'm asked to solve this using substitution. This top equation for working by hand really is not desirable because of the fractions, and anytime an equation has both fractions and an equal sign, if you want to, you can multiply each term by the same number to get rid of the fractions, and that's probably the best thing to do here. So in this problem, I'm going to multiply every term by 20. And it's going to cancel out the fractions. It's going to give me 100 to the right of the equal sign, which is a bigger number than I care to have, but I'll live with it. So when I multiply the first fraction by 20, the 5 cancels. I'm left with a 4. And that's really a 4 times 4x, which is going to make the top equation turn to a 16x. And then similarly, the 20 and the 4 are going to cancel. 20 is going to turn into a 5. I'll be left with 5 times 1y. I'm going to write a plus 5y for that. And then 20 times 5 is 100. So step 1 is I'm going to clear the fraction, because it just makes my work easier. Now I'm going to have a new system of equations that has the same answers as the original system. The top equation, I'm going to have 16x plus 5y equals to 100. The bottom one, using the substitution method, I don't need to change. X equals y plus 1. And now I'm going to substitute the x equals y plus 1 in the bottom equation into the 16x plus 5y top equation. So what I'm going to do is I'm going to change the x in the top equation with y plus 1 because told that where these two lines intersect, x is equal to y plus 1. So I'm doing that change. And when I do that change, I have to multiply the 16 by both the y and the 1. It gives me 16y plus 16 plus 5y equals to 100. On the left-hand side, I'm going to combine the 16 and the 5y, 16y and 5y. I'm also going to subtract 16, so I'm going to try to do two things at once here just to save some space. So on the left side, 16y plus 5y is 21y. And on the right side, 100 minus 16 is 84. Now I'm going to divide both sides by 21. You can do that in my head, but you can use your calculator if you can't. That gives me y equal to 4. Once I have an answer for y, I need to get an answer for x. To solve for x, I'm going to use the equation x equals y plus 1. I'm going to change the y to 4. And that gives me x equal to 5. So the answer that my calculator gave me when I did the RREF on my matrix of x equal 5, y equal 4 was perfectly the correct answer. And I don't need to, well, I could if I want to check more, but I'm not going to. I'm going to assume that since my by hand work and my calculator work matched each other perfectly, that I'm going to not check anymore just to save some time. So that's the first problem. Again, if on the test I see no work, I see a problem and an answer, I doubt that I'll give you any partial credit. It's the algebra that I'm checking more so than the answer, because the answers, you could mindlessly get the answer in some sense. So I'm going to do the same thing for number 2. I'm going to enter a matrix on my calculator, a 2 by 3 matrix, do RREFA, and that matrix is going to help me figure out what my answer is. But I'll write the answer in the bottom corner. I don't need to do a special side sheet like I did for the last problem, because this problem was set up perfectly for my initial matrix. So, error syntax, I don't know what I did. So I'm going to go second matrix. Again, this has nothing to do with actually solving the problem the way we're asked to solve. We're asked to solve this via substitution and not elimination. So I'll use substitution in a bit here. But before doing the substitution, I'm going to enter a matrix on my calculator, and that matrix is going to be a 2 by 3 matrix again. The top row is going to have the 3 that was in front of the x, the minus 2 that was in front of the y, the 5 to the right of the equal sign. The bottom row, there's no number in front of the x or the y, so there's just ones in the bottom row. The y gets a -1 in its column. So that's the matrix that's implied from the system of equations that I see there. Now I'm going to second and quit, second and matrix, over to math, find my way to RREF, second and matrix, names and enter, and really large numbers. Wow, -77 and -118. This surprises me. That's not stylistically the kind of answer I come up with. Let me check the top one. 3 times parentheses, -77. So now I'm doubting myself, and I'm physically checking by putting -77 for the top x and -118 for the bottom, for the top y. When I do that, I have a mistake somewhere. Clearly do. So let me go back. 3 times -77 minus 2. Oh, I entered it wrong. I should go, for the top row, I should go 3 parentheses -77, this minus key, and then minus 2 times -118. And it does give me 5. And then for the bottom one, if I do -77 minus -118, it also works. It was a really surprising answer. I mean, I imagine when I wrote this problem, I didn't intend the answer to be that. Just randomly kind of came out that way accidentally. Usually my answers are all under 10, and not numbers like 77 and 118. But my matrix algebra told me what the answer should be, and I should have just believed it. And so when I do this by hand, I'm shooting for that answer. Since it asks me to solve by substitution, I'm going to use substitution. On the test, if you did this problem via the elimination method, I'm not going to take points off. If you do algebra to get the right answer and you do elimination as opposed to substitution, I don't hardly care. So for me, since I'm asked to use substitution, I'll do it. I'm going to solve the bottom equation to start for x. The bottom equation was x minus y equal to 41. To solve this for x, I add y to both sides. That gets x equals y plus 41. Imagine this 41 was something I meant to be 4, and I just typed it and didn't delete the 1, but oh well. This is a slight typo here because this shouldn't say y equals. This should say x equals. Make my mistake redded. And now I'm going to substitute into the top equation. So I'm going to make a y plus 41 for the top x. So I'm going to go 3 parentheses minus 2y equals 5. And in the parentheses, I'm going to put a y plus 41 because that's what x is equal to where the solution of the system of equations exists. I'm going to clear the parentheses. 3 times y is 3y. 3 times 41 is 123. The algebra turns out not to be so bad. I'm going to do two things again at once. I'm going to minus 123 from both sides. When I minus 123 from the left side, the 123 cancels. On the right side, 5 minus 123 is minus 118. And then on the left side, 3y minus 2y is just 1y. So this gives me the y equals to negative 118 that I'm looking for, and I'm going to solve for x. I'm going to use the equation x equals y plus 41, and I'm going to change the y to negative 118. So I get x as negative 118 plus 41, and apparently that comes out to negative 77. I'm not sure I really could do that in my head, but since my calculator had that, I just believed it. So I do negative 118 plus 41. My calculator tells me that it's negative 77. Okay, so that's the first two reasonably friendly problems because there wasn't a z messing with me. I don't think any of the problems on the review have no solutions or infinitely many solutions, and you should probably have that be the case on the test. So same deal for number 3. Even though I'm asked to solve by the elimination method, that doesn't keep me from doing some side work by myself to know what the answer is ahead of time. For most of the problems on this test, you can know the answer before you get started, and there's a certain beauty to that, really. So for the top equation, for this problem to be solved by matrices, because that's the easiest way to solve this with technology, I'm going to enter a 2 by 3 matrix. I mean, this is completely optional. You don't have to do this. This has nothing to do with actually solving this problem. But knowing the right answer ahead of time, there's a certain niceness to that. So I entered the matrix that's implied by that system of equations. Second quit, second matrix math, RREF, second matrix names, enter, and it looks to me like the answer is supposed to be x equals 5, y equal to 1. If I don't get 5 and 1 for an answer, then I'll worry a little bit. So to do this by the elimination method, I'm going to drop out the y's. I'm going to make the top have a 12y, the bottom have a negative 12y. I could have also dropped out the x's, making one x a positive 10x and the other a negative 10x. The reason I picked the y's as opposed to the x's is because the y's already had opposite signs. So I'm going to multiply the top equation by 4, the bottom equation by 3, and that's going to allow me to eliminate the y's. So multiplying the top by 4, I go 4 times 2x and get 8x, 4 times 3y and get positive 12y, and 4 times 13 I think is 52. And then in the bottom equation, 5x times 3 is 15x, minus 4y times 3 is minus 12y, 3 times 21 is 63. Now when I add the equations together, 8x and 15x is 23x. The y's I set up to eliminate or cancel, and then this adds up to 115. Now I'm going to divide both sides by 23. I'm supposed to get 5 when I do that. Can't really do that division in my head so well, so I'm going to pull out my calculator and go 115 divided by 23 just to make sure it comes out to 5. And it does. So this gives me the x equal to 5. Now I need to solve for y, and there isn't a good equation to use, but I need to solve for y. I'm going to use the top equation. I'm going to use the equation 2x plus 3y equal to 13 and plug 5 in for x. The downfall of the elimination method is solving for the second letter, where the substitution method, solving for the second letter, is kind of nice. So when I go to finish this up, I get 2 times 5 plus 3y equals to 13. This gives me 10 plus 3y equals to 13. Then I minus 10 from both sides. There's a guy doing some landscaping outside the door. Hopefully it's not messing with the sound quality too much. So this gives me 3y equal to 3. And now I'm going to divide 3 on both sides and get the second part of my answer, y equal to 1. And I just write my answer as a point, x first, y second, and that seems perfect. And we're not off the screen. Perfect. All right, for nasty fractions. Nasty fractions aren't an issue when I use RREF on my calculator. So I'll do that again. Just like I've done for the first 3 problems, just like I'll do for about the first 10 problems, I'm going to do some work on my calculator before I do my algebra so I know what answer I'm aiming for. So I'm going to enter a 2 by 3 matrix here. So second matrix, edit. Top row is going to be 4 divided by 9, 2 divided by 3, 12. And then bottom row 1, -1, and 12. See the decimals there? That doesn't bother me that the decimals are there. Second and quit, then second matrix math, RREF, second matrix names, enter, and again, kind of a non-traditional answer for me. 18 is bigger than most answers that I normally come up with, but I think 18 and 6, that doesn't frighten me like the -77 answer that I came up with a little bit earlier. So I'm going to gamble that that's the right answer. I'm going to clear the fraction, so I'm going to rewrite the top equation because I don't like that top equation the way it's written. I'm going to multiply everything in the top equation by 36, or no, by 9, duh. And that's going to help me clear the fractions. So I'm going to leave the bottom equation alone for a second. And I'm going to go through and multiply every number or every term in this bottom equation by 9. The first 9 cancels completely, leaves me with a 4x. The second 9 cancels and turns into a 3. It leaves me with 3 times 2y, and I'm going to write a 6y for that. And then 9 times 12 I think is 108. Off screen I'm doing 9 times 12 on my calculator to make sure that I didn't do that wrong in my head. So I'm never going to use that top equation again. Now I'm going to stack on top of each other the modified top equation, 4x plus 6y equals 108, and put that above x minus y equals to 12. Probably easiest to drop out the y's, specifically because one y is already, the y's have opposite signs. You could make the bottom equation have a minus 4x and drop out the x's without much work, but it's easier to drop a letter if the signs are already different. And so I'm going to multiply the bottom equation by 6. I'm going to leave the top equation, 4x plus 6y equals 108. And I'm going to change the bottom equation to 6x minus 6y equals to 72. If you make a mistake, one of the most common mistakes is to forget to multiply the number to the right of the equal sign. So if you know what an answer should be and you're not getting that answer, this is one of the first places I look, is to the right of the equal sign to see if I forgot to multiply. So when I add these together, 4x plus 6x is 10x. The 6y's cancel, and 108 and 72 is 180. Again, you can do that on your calculator if you need to. Now I'm going to divide both sides by 10. And when I do that, I get the x equal to 18 that I hope to get. I need to solve for y. And again, this method, the elimination method, makes this step not as nice. I'm not sure the best equation to use, but I don't like the big numbers in some of the equations. I'm going to use the x minus y equal to 12 equation. And I don't like that equation as much as I'd like to because of the negative in front of the y, but I can still get the y from this. If I do this in minus 18, replace the x with 18, minus 18 from both sides, I get minus y is minus 6, and then I can divide both sides by a minus 1. The two minuses on each side will turn to a positive. I'll get y equal to positive 6, just like I want it to get. Alright, so now the really messy problems that you're probably going to need multiple sheets of paper for. I don't expect to be able to do this entire problem on one page because I have to do the elimination method 6 times. For both the problems on the review, from section 6.1 that have 3 equations and 3 unknowns, I give a hint. I'll give a hint on the test. If you don't follow my hint, it's going to make it a lot harder for me to, if you make a mistake, to find your mistake, and harder for me to give you partial credit. So the hint's there for a reasonable reason. Just like I've done for the last few problems, I'm going to enter this problem on my calculator and know what the answer is before I get started. But now I have to enter a 3 by 4 matrix as opposed to a 2 by 3. So I'm going to go second matrix, edit, and then 3 by 4. The top row is going to be 2, 4, -5, and -5. The middle row is going to be -1, 1, 2, and 5. The bottom is going to be 1, -3, 3, and 4. Second quit, second matrix, math, RREF, second matrix, enter, enter. Oh, really? Math, enter, enter. Really undesirable answers, to say the least. Ugh, really didn't want that to happen, but it did. That's horrible. I think the answer is going to be 11 over 14, 17 over 14, 16 over 7. I'm going to double check my matrix real quickly. Second matrix, edit. 2, 4, -5, -5. -1, 1, 2, 5. 1, -3, 3, 4. I believe that's the correct answer. I'm really not excited about having to get fraction answers, but they can happen. And with matrices, fraction answers are less of an issue than not using matrices. Since I'm not using matrices yet, it says solve by hand without matrices, the fractions will be, a nuisance, more of a nuisance than they would be with matrices. So my first step said pair the middle equation with the other two and drop out the x's. So I'm going to do that. I'm going to take the middle equation, -x plus y plus 2z equals to 5. Put it on top of the top equation, which is 2x plus 4y minus 5z equals negative 5. And take that same middle equation, negative x plus y plus 2z equals to 5, and put it on top of the bottom equation, x minus 3y plus 3z equals to 4. I said to drop out the x's, so I'll do that. For this first pairing, I need to multiply the top equation by 2 to drop out the x's. So this is what my goal is for the answer. I suspect I'm going to take 2 sheets of paper, so I didn't write my answer in the bottom corner because I didn't think that was going to be the end of the problem. So the top equation can become minus 2x plus 2y plus 4z equals to 10. I can leave the bottom equation, 2x plus 4y minus 5z equals to negative 5. Add these together, I get 6y minus z equals to 5. The other pair that I have, to drop out the x's, I can just add them together. They're already set up to drop out the x's. So when I add these together, y plus minus 3y is minus 2y. 2z plus 3z is plus 5z. And 5 plus 4 is 9. Now I'm going to stack these equations on top of each other. So I'm going to put the 6y minus z equal to 5 on top of the minus 2y plus 5z equals to 9. Both letters are pretty easy to drop out. I don't know. Let me drop these z's for whatever. Dropping the y's wouldn't have been that much harder. But I'm going to drop the z's by plugging a 5 in. Multiplying the top equation by 5. When you do that, you get 30y minus 5z equals to 25. I'll leave the bottom at minus 2y plus 5z equals to 9. I add this together, I get 28y equals to 34. I'm going to divide both sides by 28. And on the left side, I get a nice simplification. On the right side, both of those are divisible by 2. 34 divided by 2 is 17. 28 divided by 2 is 14. That's the 17 over 14 part of my answer. Now I'm going to solve for y. I'm going to do this right off to the side here. So I'm going to solve for y. To do that, I'm going to use this top equation. 6y minus z equals to 5. And I'm going to change the y to 17 over 14. So I'm going to go 6 times 17 over 14 minus z equals to 5. And then I'm going to, well, this will cancel. The 6 and the 14 will cancel. The 6 will become a 3. The 14 will become a 7. I'm going to multiply the 3 times the 17 and get 51. So this gives me 51 over 7 minus z equals to 5. I'm going to be semi-slick. I'm going to add z and minus 5 from both sides. If I do that combination, the adding the z to the right side will get the z on the right side. On the left side, it will cancel my z's. So now I need to go 51 over 7 minus 5, and I'm going to be lazy and cheap. My calculator can chew up fractions quicker than I can. So I'm going to do this right here on my calculator. Specifically, 51 over 7 minus 5. So I'm going to go 51 divided by 7 minus 5, enter. Ugly decimal, which is not a terrible issue because if I hit math and enter twice, my calculator gives me the 16 over 7 that I wanted to get. So I'm 2/3 of the way done because I have my answer for y and my answer for z. I'm going to go on. I can solve for x on this page. So Yeah, I can do that. So I'm going to solve for x just to try to get this all on one page. I'm going to use the bottom equation. The bottom equation is x minus 3y plus 3z equals to 4. I'm going to go x minus 3 times 17 over 14 for the y plus 3 times 16 over 7 for the z equals to 4. These two fractions I don't want to deal with. I'm going to do these on my calculator right here. I'm going to get x something equals to 4. So again, I'm going to use my calculator. I'm going to go 3 parentheses 17 divided by 14 plus, should be minus 3 then, should be minus 3 parentheses 17 divided by 14 plus 3 parentheses 16 divided by 7, and then math, enter, enter. So this gives me x plus 45 over 14 equals to 4. And now I'm going to minus 45 over 14 from both sides. So I'm going to go minus 45 over 14 minus 45 over 14. And when I do that, on the left-hand side, I get my x. And on the right side, 4 minus 45 over 14, I'll also do it on my calculator. So I'm going to go 4 minus 45 divided by 14, math, enter, enter, and I get 11 over 14. So I try to minimize my calculator, my algebra, by using my calculator to choose through those fractions. So down here, I did, calculator. So I used calculator to work on do fraction. And that just made my work quite a bit easier to do. That way I still have the correct answer. So this answer up here was correct. You can shove it down here if you really want it, because I'm used to putting the answer in the bottom corner. The answer is x is 11 over 14, y is 17 over 14, and z is 16 over 7. I managed to get it on one sheet. Alright, so hopefully we don't run into fractions a second time here for problem 6. So same deal for problem 6. I'm going to eventually follow my instructions, but before I do my instructions, I'm going to enter a 3 by 4 matrix. 2, 1, negative 5, 3, negative 3, 2, 5, 0, 1, negative 1, 1, 4, second quit, second matrix, math, RREF, second matrix, enter, enter. Really? Math, enter, enter. Oh, I really don't want double fractions. It was really unfortunate. Let me double check this. Second matrix, make sure I entered it right. 2, 1, negative 5, 3. Negative 3, 2, 5, 0. 1, negative 1, 1, 4. How horrible is that? So the answer, again, is going to be fractions. I guess at this point in a college algebra class, fractions shouldn't, keep us from getting to the correct answer. But really, they're not, my preference either. I'd rather have nice integer answers. So my equation, my hint said pair the bottom with the other two and drop out the y, so that's what I'm going to do. I'm going to take the bottom equation, x minus y plus z equals to 4, pair it with the top equation, 2x plus y minus 5z equals to 3, and take the bottom equation, x minus y plus z equals to 4. Pair it with the middle equation, negative 3x plus 2y plus 5z equals to 0. And drop out the y's because that's what my hint says to do. Honestly, if you did the problem differently, you could get the same answer. There isn't a right nor wrong way to start. But if you're trying to check yourself if you made a mistake, it'll be a lot easier to solve the problem like I solved the problem. That way you can match your work to my work. So for the first pair, easy enough to drop the y's. You just add the equations together and the y's are going to drop. So I'm going to go 2x plus x is 3x. Y's cancel. Z minus 5z is minus 4z. And 4 plus 3 is 7. I don't know why I wrote that in a different color, but I did. It's okay. This next set, I'm going to multiply the top by 2. When I multiply the top by 2, I'll put it over here just to save vertical room. I get 2x minus 2y plus 2z equals to 8. And I can leave the bottom minus 3x plus 2y plus 5z equals to 0. Add these together, I'm going to get minus x plus 7z, because the y's are going to cancel, equal to 8. So I'm going to stack these two equations on top of each other. So I'm going to put the 3x minus 4z equal to 7 on top of the minus x plus 7z equals to 8. And I'm going to solve these using the elimination. The first thing I'm going to do is drop out the x's. And again, I'm going to save some vertical room by going this way. I'll leave the top row 3x minus 4z equal to 7. Multiply the bottom by 3 and get negative 3x plus 21z equals to 24. When I add these together, really, I get, oh, no I don't. I thought I was getting something nicer. I get 17z equals to 31. I divide both sides by 17. And I get z is 31 over 17, like I expected to get. Now I'm going to solve for x. It's probably easier to use this bottom equation because the x doesn't have a number in front of it, so I will. It has a negative in front of it, so I'm going to go negative x plus 7z equals to 8. And I'm going to put the 31 over 17 in, so I'm going to get negative x plus 7 times 31 over 17 equals to 8. And I can do that multiplication on my calculator, 7 times 31 over 17. So I'm going to go 7 parentheses 31 divided by 17. And math, enter, enter. So this gives me negative x plus 217 over 17 equals to 8. I'm going to minus 217 over 17 from both sides. This I'm going to do on my calculator. And this is going to give me minus x equals to whatever 8 minus 217 divided by 17 equals. And then math, enter, enter. So this gives me minus x equals minus 81 over 17. I divide both sides by a negative 1. And I get x equals to 81 over 17 like I hoped to. Last thing I need to do is get an answer for y. To get an answer for y, I'm going to use the top equation. So last, give myself a little bit room. Solve for y. I'm going to use the top equation because the y is positive in it, and it doesn't have a number in front of it. So I'm going to use 2x plus y minus 5z equals to 3. And for the x, I'm going to do 81 over 17. And for the z, I'm going to do 31 over 17. Now I'm going to simplify the left-hand side using my calculator. So for this stuff, I'm doing it in one step on my calculator. And it's going to give me y, and then I'll have some number after it. And that number after it, I'll find out quickly here by going 2 parentheses 81 divided by 17 minus 5 parentheses 31 divided by 17. That's just doing the multiplications, and then math, enter, enter. So that's going to give me plus 7 over 17. So my calculator gives me y plus 7 over 17 equals to 3. I'm going to minus 7 over 17 from both sides. On the left-hand side, when I do that, I get my y. On my right-hand side, again, I'm going to pull out my calculator. I can do fraction work by hand, but I don't have to, so I'm not going to. I'm going to go 3 minus 7 divided by 17 on my calculator, and then do math, enter, enter, and it gives me 44 over 17, which is good because that's the answer that my calculator told me I should get. So in for my answer, I'm going to write the x first, which is 81 over 17, the y second, which is 44 over 17, and the z third, which is 31 over 17. Messy, but at least, I mean, not horrible. If you pull out your calculator to do the grungy fraction work, then it doesn't become as humbling as if you try to do all that fraction work by hand. Okay, done with section 6.1, now into 6.2. 6.2 wants me to use matrices and row operations to solve. It's kind of what I've been doing on my calculator. So first number 7, the first thing I need to do is get my initial matrix. I've kind of been doing that already as I did the last 6 problems. My initial matrix is going to have 1, 2, 10, 2, negative 3, and negative 1. I need to have a final matrix, which I can get from my calculator, and an answer, which I also can get from my calculator because it's sitting in the final matrix. These don't take that much room. It's the next page, when you have the 3 equations that they take a lot of room. So I'm doing this as a 2 by 3 matrix, entering the coefficients the best I can, hopefully not running into fraction answers. And then after I have these in, second matrix, second quit, matrix math, second matrix names, haha, beautiful. So the answer to this is supposed to be 4, 3, and my final matrix is going to be 1, 0, 4, 0, 1, 3. If you don't show a second matrix, then you're not going to get partial credit for just having a correct answer. To get from my first to my second matrix, I need to make that a 0. And to make that a 0, I'm going to multiply the top row by negative 2 and add the rows together to get that to be a 0. So I'm going to go negative 2 times the top row, which will give me negative 2, negative 4, negative 20. And I'm going to leave the bottom row at 2, negative 3, negative 1. And when I add these together, I get 0, negative 7, negative 21. Before I make my second matrix, because every number in this row is divisible by negative 7, I'm going to divide by negative 7 and get 0, 1, and 3 for my new bottom row. So that's going to lead me to the second matrix. The second matrix is going to have the same top row of 1, 2, and 10, and a new bottom row of 0, 1, and 3. The next step is to make this into a 0. To do that, again, I'm going to multiply by negative 2, but this time the bottom row by negative 2. When I do that multiplication, I'm going to leave the top row at 1, 2, and 10. multiply the bottom row by negative 2. Negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 3 is negative 6. I add these together and get 1, 0, and 4. That's going to be my new top row. Their top row is already there. So I'm going to take this matrix that had 0, 1, 3 as a bottom row, make it have a new top row of 1, 0, 4. I've got from my second matrix to my final matrix. There's no more matrix work to do, and the answer is going to be sitting in the right-hand column. So I'm done with problem 7. So the matrix problems that only have the x's and y's, they don't take a lot of room. The only matrix you need to come up with by hand is the second matrix, because the initial matrix and the final matrix kind of come without any thought in some sense. Same deal for number 8. I'm going to do my initial matrix, enter it on my calculator to get my final matrix. My initial matrix is going to be 3, negative 2, 11, 1, negative 7, negative 10. And then somewhere down here, I'll put a final matrix. And also somewhere down here, I'll write my answer. So when I enter this matrix, second matrix, edit, it's another 2 by 3 matrix. And when I enter it as 3, enter negative 2, enter 11, 1, enter negative 7, enter negative 10, second and quit. Second, since I just did RREF, just second and enter pulls up the RREF again. Ugly decimals, which means fractions, which is really horrible. Before I commit to writing this answer down, I'm going to check to make sure I haven't entered something wrong. 97 over 19 and 41 over 19 aren't desirable answers, but they're not bad. When you're working matrices, fractions are less imposing than when you do the other kinds of problems without matrices, the elimination method. So let me just double check this. Second matrix, edit. 3, negative 2, 11, 1, negative 7, negative 10. So that's what I'm shooting for, 97 over 19. And 41 over 19. I'm probably going to get a second and a third matrix because of the fraction answers. I pick up an extra middle matrix. So to get my second matrix, I'm going to make this into a 0. To make that into a 0, I'm going to multiply by negative 3. If I do this, I can leave the top row at 3, negative 2, and 11. Multiplying the bottom by negative 3, I get negative 3, positive 21, positive 30. If I added these together, the 3's cancel. Negative 2 plus 21 is 19, and 30 plus 11 is 41. I could divide by 41 and get my 41 over 19, but that would require me to do algebra with fractions, and I don't want to. So I'm going to leave the bottom row. So this is going to be my new bottom row. I'm going to get a second matrix, and again, when I have fraction answers, I usually get a second and a third matrix. So my second matrix is going to have a 3, negative 2, 11, and then 0, 19, and 41. I need to make this negative 2 now into a 0. So I'm getting my zeros one column at a time. To do this, I'm going to make this a negative 38, this a positive 38. I'm going to multiply the top row by 19, the bottom row by 2. Top row by 19 is pushing me a little bit. 3 times 19 is 57. So when I do the top row by 19, I get 57. 19 times negative 2 is negative 38. And then 19 times 11 is 209. Bottom row by 2, 0 times 2 is 0, 19 times 2 is 38, and then 41 times 2 is 82, add these together, I get 57, 0, and then 209 plus 82 equals 291. Those are both divisible by 3, but I'll do all my division at once here in a second. So I'm going to do a new top row and get my third matrix. So when you have fraction answers, you pick up an extra matrix. My third matrix is going to be 57, 0, 291 for the top, and the same 0, 19, and 41 for the bottom. And now I'm going to divide. I'm going to take the top row and divide by 57. So I'm going to go 57 over 57, 0 over 57, 291 over 57. I'm going to take the bottom row and divide it by 19. I'm going to go 0 divided by 19, 19 divided by 19, and 41 divided by 19. Most of these divisions I can do. 57 divided by 57 gives me a 1. 0 divided by 57 gives me a 0. And 291 divided by 57, I'm going to gamble and think it comes out to 97 over 19. I'm going to check that. I'm going to go 291 divided by 57 and math, enter, enter. I see 97 over 19 like I suspected would happen. And then for this one, 0 divided by 19 is 0. 19 divided by 19 is 1. And apparently 41 over 19 doesn't reduce because in my answer 41 over 19 was there. So I'm going to take this to make this my top row. 1, 0, 97 over 19 to make this my bottom. So this is going to be new top. This is going to be new bottom. So to get from my third matrix to my final matrix, I just do the division to get the answers to pop out. So the answer is going to be x equal 97 over 19, y equal 41 over 19. It's already 3 problems with fraction answers. I would be surprised if there are 3 problems on the test that have fraction answers, but I don't mind making the reviews a little bit harder than the test, so we'll just live with it. 9, there's no way I can do this on one sheet. I'm going to need 2 sheets of paper to get through number 9. Similarly, 10, I'll need the same. So I'm going to enter the 3 by 4, well, I'm going to write my initial matrix and hope like heck I don't have initial matrix, and hope like heck I don't get fraction answers again. So 1, 1, 1, and 6, 3, negative 2, 3, and 3, 5, negative 4, negative 3, and negative 5. Enter my initial matrix, second matrix, edit. This is a 3 by 4 matrix, and 1, 1, 1, and 6, 3, negative 2, 3, and 3, 5, negative 4, negative 3, negative 5, second quit, second matrix, math, RREF, second matrix, enter, enter, 2, 3, 1. That's my classic kind of answer. I'm not even double checking that I entered this right. On the bottom of my second page of work, I'm going to write my answer that I'm shooting for and my final matrix that I'm shooting for. I know this is going to take 2 pages. So the answer that I'm shooting for is x equal 2, y equal 3, z equal 1. And the final matrix that I'm shooting for is 1, 0, 0, 2, 0, 1, 0, 3, 0, 0, 1, 1. Takes 6 elimination methods to get from the initial matrix to the final matrix. That's when you don't have fractions. So, first step, but a pair row 1 with the other 2 and get zeros. Specifically, I'm going to get this 0 and that 0. Let me do the pairing just so I can keep things organized. So the top row is 1, 1, 1, 6. I'm going to pair it with the middle row, 3, negative 2, 3, and 3. Pair it with the bottom row, 5, negative 4, negative 3, and negative 5. And specifically, I want that to be a 0, and I want that to be a 0. To do that, I'm multiplying the top row. For this one, I'm going to multiply the top row by negative 3 to make the 3's cancel. For this one, I'm going to multiply the top row by negative 5 to get that 5 to cancel. And that will give me a new second row and a new bottom row in a minute here. So top by negative 3 gives me negative 3, negative 3, negative 3, negative 18. That's just multiplying everything in the top row by negative 3. Leave the bottom row at 3, negative 2, 3, and 3. Add these together, I get 0, negative 5, 0, negative 15. Can certainly divide that by negative 5 to make good things happen. This problem could be simplifying quicker than usual. I don't know if it will or won't, but at this point it looks good because this looks like I already have the answer for y at y equal to 3, but that's going to be my new middle row. Now I'm going to go for my new bottom row by doing this work over here. Multiplying the top by negative 5 gives me negative 5, negative 5, negative 5, negative 30, leaving the bottom at, or this row at 5, negative 4, negative 3, and negative 5. Adding these together, I get 0, like I hope to get, negative 9, negative 8, negative 35. I'm going to double check that because I don't like those numbers as much as I like the other numbers. So I'm checking them in my head. Oh well, I don't know, negative 5, negative 30, boom, 0, negative 9. I don't see a mistake. I could make all those things positive by dividing by negative 1, but I'm not gonna. I don't mind having some negatives around. Sometimes it makes canceling easier. So my second matrix, the top row of 1, 1, 1, and 6 is going to hang out and be the same. The middle row is going to go to 0, 1, 0, 3. In the bottom row, I have 0, negative 9, negative 8, negative 35. That's step 1. That gives me my second matrix. Now I'm going to pair the middle row, or row 2, which is the middle row, with the other 2 and get some more zeros. So I did the zeros in the first column. Now I'm going to do the zeros in the second column, pairing the middle row, which I can also call row 2, with the other 2. So I'm going to go 0, 1, 0, 3. Pair it with the top row of 1, 1, 1, and 6. And also 0, 1, 0, 3. Pair it with the bottom row, 0, negative 9, negative 8, negative 35. And when I do my pairings, I circle the things that I want to make a 0. I want to make that a 0. I want to make that a 0. So I have these targeted so I kind of know what to multiply by. For the first pair, I'm going to multiply the top by negative 1. That's going to give me a negative 1 and a positive 1 and give me the 0 I'm looking for. In the second pair, I'm going to multiply by 9 to get a 9 and a negative 9 to give me the 0 that I'm targeting. So I'll do that. For this one, multiplying anything by 0 is 0, so I get 0, negative 1, 0, negative 3 when I multiply that by negative 1. If I leave this 1, 1, 1, 6 and add these together, I get 1, 0, 1, and 3. This is going to be my new top row. And in a second here, I'm going to get my new bottom row. Multiplying this by 9, 0, 9, 0, 27. Then I have 0, negative 9, negative 8, negative 35. When I add these, I get 0, 0, negative 8, and negative 8. I'm going to divide by a negative 8. So I'm going to go 0 divided by negative 8, 0 divided by negative 8, negative 8 divided by negative 8, and negative 8 divided by negative 8. And that's going to give me 0, 0, 1, 1 for my new bottom. So I'm going to go from my second matrix, which I'm going to need to see when I grade your test, to my third matrix. My middle row of 0, 1, 0, 3 is going to stay, but my top and my bottom row are going to change. So my third matrix, which is the last matrix that I'll look for when I'm grading, well, I'll look for the final, but I assume you have that right anyways. So my third matrix, again, this is problem number 9, is going to have the new top row of 1, 0, 1, and 3, and not a new middle row. The middle row is going to stay 0, 1, 0, and 3, and the bottom row is going to be 0, 0, 1, and 1, because that's what I wanted to do. I wanted the new top row of 1, 0, 1, 3, new bottom row of 0, 0, 1, 1. Last step is to pair the bottom with the other two. So I'm going to try to get these to be zeros, pairing with the bottom row. The nice thing about this one is I already have one of the zeros, so I don't need to pair the bottom with the middle. I only need to pair the bottom with the top. To go from my third to my fourth matrix, when I already have one of the targeted zeros, I don't need to do both pairings. So the only pairing I need to do is I need to pair the bottom with the top. I don't really need to pair the bottom with the middle because the 0 that I have circled is already there. So what I need to get here is I need to get that to be a 0. And I'm going to get that to be a 0 by multiplying this top by negative 1. And that's going to give me 0, 0, negative 1, negative 1 on top of 1, 0, 1, and 3. When I add these together, I get 1, 0, 0, and 2. That's going to be my new top row. And there it is. The middle row at 0, 1, 0, 3 was already okay. The bottom row at 0, 0, 1, 1 was already okay. From my third matrix to my final matrix, I only needed to improve the top row, which I just did. And so my answer of 2, 3, and 1 in my final matrix match up with my work, and that's what I want them to do. That's the end of problem 9. Problem 10 is also a grungy problem that will take me multiple sheets of paper. Ultimately, I'm going to write down a final matrix on my second sheet of paper. Hopefully, it starts to look like this. And an answer. And again, I hope I'm not running into fractions. If I run into fractions, then I'm going to need to leave myself more room there because I didn't even leave room for fraction answers. So in problem 10, I'm going to, in a second, use my calculator to get that final matrix. And before I break into my calculator, because I'm doing these things by hand, I'm going to write the initial matrix down. The initial matrix is 1, negative 1, 1, 3, 2, 1, 1, 13, 7, negative 4, negative 5, and positive 6. Enter that as a 3 by 4 matrix. Do RREFA. So second matrix, calculator. Second matrix, edit, 3 by 4, and enter 1, enter negative 1, 1, 3, 2, 1, 1, 13, 7, negative 4, negative 5, and 6. As you can see them, but they're entered, I believe, correctly. And then second quit, second matrix, math, RREF, second matrix, enter, enter, beautiful. Again, with the nice solid integers in the right-hand column. That's what I want to have happen more often than not, so I'm not seeing fractions. So my final matrix was this. The answers are going to be x equals 4, y equal to 3, z equal to 2. So again, if you stopped here and just wrote that down, you wouldn't get any partial credit. What I'm really going to give partial credit for is the second and the third matrix. So I'm going to try to get the second matrix. And first step is to pair the top with the other two. So specifically, I'm going to go 1, -1, 1, and 3. Pair it with the middle equation of 2, 1, 1, and 13. And the top 1, -1, 1, and 3 with the 7, -4, -5, and 6. I'm going to make this 2 and this 7 into a 0. To make the 2 into the 0, I'm going to multiply this top by -2. To make this 7 into the 0, I'm going to multiply this top by -7. And when I do that, hopefully good things will happen. Maybe I'll get some things that divide nicely. So multiplying this by -2, I get -2, +2, -2, -6 on top of 2, 1, 1, 13. Adding those together, I get 0, 3, -1, and 7. That's going to be my new middle, our second row. Use those middle and second interchangeably. Multiplying this by -7, I get -7, +7, -7, -21. Writing that on top of 7, -4, -5, and 6. I get 0, 3, -12, and -15. If I did that properly, which I think I did, double check. Yes, this I'm going to divide by 3. So I'm going to go divided by 3, divided by 3, divided by 3, divided by 3. This is going to give me my new bottom. It's going to be 0, 1, -4, and -5. So my second matrix, which is a big deal in terms of grading, the top row can stay at this 1, -1, 1, and 3. I get a new middle of 0, 3, -1, and 7, and a new bottom at 0, 1, -4, and -5. Your second matrix could be slightly different than mine, but not that different than mine. You could maybe have some different signs, but the way I do the matrices, it doesn't give you a lot of flexibility in how you get to your second matrix. So there's not a lot of variety of answers. Next step is I'm going to pair the middle with the other two, get some more zeros. I'm going to get this to be a 0 and that to be a 0. So I'm going to take the middle, which is 0, 3, -1, and 7. Pair it with the top, 1, -1, 1, and 3. Also the 0, 3, -1, and 7. Pair it with the bottom, 0, 1, -4, and -5. Again, I like to circle what I'm trying to make zeros. I like to use multicolors too. Just makes it easy for me to keep my work straight. If I don't keep my work completely organized, I start to go down the wrong path and bad things happen. So for this, I'm going to multiply this by 3 to get a positive and a -3. Here I'm going to multiply this by -3 to get a positive and a -3 for my canceling. So this set, I'm going to leave the top at 0, 3, -1, and 7. Multiply the bottom by 3 and get 3, -3, 3, and 9. Add these together, I get 3, 0, 2, and 16. Because that came from something in the top row, that's going to be my new top. For the other pair, leave the 0, 3, -1, and 7 alone. Multiply this by -3, get 0, -3, 12, and 15. Add these together, I get 0, 0, 11, and 22. I'm going to divide these by 11 and get 0, 0, 1, and 2 for my new bottom. So I'm getting ready to write down my third matrix. My third matrix is going to have a top row of 3, 0, 2, 16, a middle row of this 0, 3, negative 1, 7, and a bottom row of 0, 0, 1, 2. And that's what I have my other sheet of paper that I knew I just never can do these on one sheet of paper. So I give you an entire sheet of paper or on the test, and if you need to use extra, use extra. So I said the new top was going to be 3, 0, 2, and 16. So you could bring scrap paper on this test if you write big like I do. The middle row is staying at 0, 3, negative 1, and 7. The bottom row was writing 0, 0, 1, and 2. So again, I'm just being consistent with what I said here. So that I had a new top row, a new bottom row. My middle row wasn't changing on that step. Last thing I need to do is pair the bottom with the other two. So first I pair the middle, first I pair the top, then I pair the middle, then I pair the bottom. And this again, this was my third matrix, which is a big deal in terms of partial credit. So I'm going to take the bottom of 0, 0, 1, and 2, pair it with the top, 3, 0, 2, and 16, and take the bottom 0, 0, 1, and 2, pair it with the middle, 0, 3, negative 1, and 7. Again, I like to circle what I'm trying to make zeros so I know what I'm shooting for here. For this first set, I'm going to multiply the top by -2 to get the 2 to cancel. The second set, I don't need to do any multiplying. I can just add them together. So here, multiplying the top by -2, I get 0, 0, -2, and -4 on top of 3, 0, 2, and 16. This is going to give me 3, 0, 0, and -4 and 16 is going to be 12. I'm going to divide by 3. And get 1, 0, 0, 4. This is going to be my new top, which I see 1, 0, 0, and 4, which is a good thing. These two I'm just going to add together. I get 0, 3, 0, and 9. I'm going to divide these by 3, which is going to give me 0, 1, 0, and 3. That's going to be my new middle, which I see as my middle, and my bottom didn't change at 0, 0, 1, and 2. So this is the step to link the third matrix to the final matrix, because in the final matrix, my bottom row was already okay. I have a new top row and a new middle row. Already had the final matrix and my answer done because my calculator does that for me. That's the end, hopefully, of the grungy stuff, and hopefully the rest isn't quite as horrible. Oh, Kramer's rule. Well, only 2 problems by Kramer's rule. I'm still going to get the answer using RREF. So for 11 and 12, for 11, I'm still going to enter a 2 by 3 matrix and know what the answer is ahead of time because I can. Kramer's rule isn't the quickest tool for checking. RREF for me is the quickest tool for checking, and I love to have to know that my answer is correct. So I'm pretending that the instructions don't exist, and I'm solving this problem. Ugly decimals. I believe the answer is going to be 29 over 24, comma, -1 over 12. I'm going to double check my matrix. I see 4, -2, 5, 2, 5, 2. Not such a horrible thing, but not great either. So I know for Kramer's rule, I need to know the x column of numbers. The x column is 4 and 2. I need to know the y column of numbers, which is -2 and 5. And I know the equals column is 5 and 2. I need 3 matrices. I need a D matrice, a D sub x matrice, and a D sub y matrice. The D has the x column and then the y column, which is 4, 2, -2, 5. The D sub x has the equal column, then the y column. The equal column is 5 and 2. The y column is -2 and 5. And the D sub y has the x column and then the equal column, which is the 4, 2, 5, 2. Need to do 3 determinants. do them all on my calculator because I can mindlessly do them on my calculator. I'm going to enter all these as a 2 by 2 matrix. So for the first one, I'm going to enter D as a 2 by 2 matrix. And when I do this, it's, well, I already have it in 4, negative 2, 2, 5. So it's in, second quit, second matrix math, determinant, second matrix enter, enter. The determinant for matrix D is 24. You can do all the determinants on your calculator. I don't care. You don't have to do those by hand, although they're not hard to do by hand. Enter the next matrix, second matrix, edit another 2 by 2 matrix. And when I enter this, I go 5, enter, negative 2, enter, 2, enter, 5, enter. Second quit. I just did determinant, so second enter and enter. This determinant is 29. And then my last determinant, the D sub y, second matrix, edit, edit. I go 4, enter, 5, enter, 2, enter, 2, enter. Second quit, second enter, and that comes out to be negative 2. So now that I set up my determinants, I calculated each. I know that x is the D sub x determinant over the D sub determinant. The D sub x is 29, the D is 24. That's a fraction that doesn't reduce. There's my answer for x. The y answer is the D sub y number divided by the D number. The D sub y number is negative 2. The D number is 24. That fraction reduces by 2 to negative 1 over 12. And that's why my calculator came up with 29 over 24 for x, negative 1 over 12 for y. And that's the perfect answer for that problem. 12 is another Kramer's rule. I'm going to need 4 determinants. A D sub x, a D sub y, and a D sub z. Again, if I'm doing this problem, make sure again I get something flying off the screen here. If I'm doing these problems, I want to do my answer ahead of time. So my answer, I'm going to get by doing RREFA, like I did for the beginning problems, even though it's not how I'm solving the problem. It's the easiest way for me to get an answer, so I know that my answer is correct when I generate it. So I'm going to do a 3 by 4 matrix, do RREFA in a second here. 1, 2, negative 1, 6, 3, 5, negative 4, 13, 4, negative 2, 1, 19. So for every single problem, I am checking my answer if I can beforehand, which is I can for most of the problems in this test. Good. So I believe these answers are going to be 5, 2, and 3 for x, y, and z. Again, I need to know my columns now. The x column of numbers are 1, 3, and 4. The y coefficients are the y column is 2, 5, and negative 2. The z column is negative 1, negative 4, and 1. The equals column is 6, 13, and 19. I need 4 determinants. The D determinant has the x column, the y column, and the z column. The x column being 1, 3, and 4. The y column being 2, 5, and negative 2. The z column being negative 1, negative 4, and 1. I'm going to just do this determinant. I'm going to enter this as a 3 by 3 matrix. So second matrix, edit, enter, 3, enter, 3, enter. And when I enter that, I'm going to go 1, 2, negative 1, I think it's already in right, 3, 5, negative 4, 4, negative 2, 1. Get it in, second quit, second matrix math, determinant, second matrix enter, enter. So the D number is going to be negative 15. Mindlessly did that on my calculator. Doing these determinants by hand is just not something that I'm going to worry about. You're not probably going to see determinants again unless you take linear algebra. Maybe Calc 3 might have some in there. Now the D sub x, the x column changes to the equal column, 6, 13, and 19. The y column stays, the 2, 5, negative 2. The z column is the negative 1, negative 4, and 1 still. Enter this on my calculator, second matrix edit. It's another 3 by 3 matrix. 6, 2, negative 1, 13, 5, negative 4, 19, negative 2, 1. Second and quit, second, enter, enter. The a, d sub a is negative 75, or d sub x should I say. Now I'm going to do the d sub y. The d sub y has the x column of numbers, 1, 3, and 4. The equals column, 6, 13, and 19. And the z column, negative 1, negative 4, and 1. I'm going to enter that on my calculator and do its determinant. So second matrix, edit, another 3 by 3, 1, 6, negative 1, 3, 13, negative 4, 4, 19, 1. Second quit, second enter, enter. I get negative 30 for the d sub y. And I have one last determinant to do. We call that d sub z. It has the x column first, 1, 3, 4. The y column second, 2, 5, negative 2. And the z column last, 6, or the equal column last, 6, 13, and 19. And when I do that determinant, again, mindlessly on my calculator, second matrix, edit another 3 by 3 matrix, 1, enter, 2, enter, 6, 3, enter, 5, enter, 13, enter, 4, enter, negative 2, enter, 19, enter, second quit, second enter, enter, and I get negative 45 for that number. Basically done, because now the x is going to be the d sub x number over the d number. The d sub x number is negative 75. The d number is negative 15. When I divide those, the two negatives cancel to be a positive, and 75 over 15 is 5. For the y is going to be the d sub y number over the d number. The d sub y number is negative 13. The d number is negative 15. The two negatives cancel to be a positive, and those numbers divide to be 2. And lastly, the z is going to be the d sub z number over the d, and the d sub z number is negative 45. The d number is negative 15, and when I divide those, I get the 3 that I'm hoping to get. All right, I'm going to pause the video and do this in 2 parts because I think it's getting kind of long. This way it gives you kind of a place to break if you need to.